All right, so get this. Today, we are diving into computer vision. But with a twist, you sent over this paper. An image is worth 16 by 16 words. Transformers for image recognition at scale.
Yeah.
And I'm already intrigued. You know I love a good mystery.
And a mystery it is.
Yeah.
This paper, what they're doing is they're exploring using transformers, which have been, making big waves in language processing, to actually understand images.
Okay.
So imagine like teaching a computer to see using the same technology that powers like your favorite translation app, for example.
Wait, really? I always thought those image recognition things, like the ones that identify my dog as a loaf of bread sometimes,
Yeah.
ran on a completely different type of technology.
You're right. They usually do. Traditionally, it's been all about what are called convolutional neural networks, or CNNs for short, for image recognition.
Okay.
Think of them as like being great at spotting patterns, edges, that kind of thing, in visual data.
Yeah.
But this paper, what they decided to do was shake things up a bit.
So instead of using something designed for images, they went with transformers, which were built for understanding language.
Exactly.
That's a bold move.
It is, and what's really interesting is they actually found that with enough data, these transformers can actually start to rival, and in some cases even outperform, these more traditional CNN models.
Wow.
But to understand how they pulled it off, we need to kind of unpack how a transformer, which usually deals with like words in a sentence, can even begin to see an image.
Yeah, that's what I'm curious about. It's like trying to teach a chef to paint.
Yeah.
Totally different mediums.
That's a great analogy. And this is where, things get really clever, right? So instead of feeding the transformer a whole image at once, what they do is they break it down into these smaller patches.
Okay.
And each patch is only 16 by 16 pixels.
So they're essentially chopping up the image into like bite-sized pieces.
Precisely.
Okay.
And these little patches, they become like the words for the transformer to analyze.
Okay, so I'm starting to see how they're bridging the gap between language and vision here.
Yeah.
But how does the transformer know where each word or patch, I guess, belongs in the bigger picture?
Right. So they thought of that too. They added something called position embeddings to each patch. It's essentially like giving each piece a little address label.
Okay.
So the transformer doesn't lose track of where it fits within the overall image.
Clever. But didn't you mention something about these transformers being a bit data hungry?
Ah, yes. That's the catch. They need a lot of data to learn effectively.
Okay.
We're talking about massive data sets with millions upon millions of images.
Wow.
For this research, they actually used ImageNet, which is already huge, but they even went further and used ImageNet-21k, and a gigantic data set from Google called JFT-300M.
Wow. They weren't messing around.
Sure.
So they force-fed this transformer images until it could recognize a cat in a pixelated thumbnail.
That's a funny way to put it, but yeah, you're not wrong. With all that data, the model, which they call the vision transformer, or VIT, started to show some really impressive results.
Okay, I'm on the edge of my seat. Did all that data crunching pay off? So all that data training, all those images, it led to this VIT model. And then they had it go head-to-head with, like, the reigning champ of image recognition, ResNet.
Right.
What happened? Who won?
So it's fascinating. In some tests, VIT actually outperformed ResNet.
What?
And get this, sometimes with less computational effort.
Oh, wow.
So less work for potentially better results, that's a big deal.
That's huge. Okay, so I have to know, how is VIT seeing these images to be so effective?
Yeah.
Like, is it interpreting them the same way we do, or is it something totally alien to us?
That is the million-dollar question, isn't it? And the researchers were curious about this too.
Yeah.
They wanted to understand what was happening inside VIT's like brain.
Yeah.
How it was representing these images internally.
So they were basically trying to decode the secret language of VIT.
Exactly. And what they found is that VIT uses this thing, well, it uses attention, which allows it to focus on certain parts of the image.
Okay.
Much like our own eyes are drawn to specific details when we look at something.
Okay, that makes sense. So, like, if I see a picture of a cute dog, my eyes are immediately drawn to, like, its goofy grin and its floppy ears.
Yeah.
Like, I focus on those important, adorable parts. So is that kind of what VIT is doing?
Yeah, that's the gist of it. But here's where it gets really cool. What they discovered is that different parts of VIT actually focus on different levels of detail.
Oh.
So some parts are all about those minute details, the texture of the dog's fur, or the
Yes.
sparkle in its eye.
Yeah, yeah.
Other parts are more focused on the bigger picture. So, the dog's overall pose or its position in the image.
Wow, so it's almost like VIT has this team of experts inside.
Yeah.
You've got your detail-oriented folks, and then you've got your big picture thinkers, and they're all working together.
A perfect analogy.
That's really interesting.
And this ability to process these images on multiple levels is a big part of what makes VIT so powerful.
That's incredible. So VIT is learning to see these images in this amazingly complex, nuanced way. And it's even giving these CNNs a run for their money. So where do we go from here? What's the next step for this technology?
Well, remember how we talked about VIT needing those massive data sets to learn effectively?
Yeah.
So one thing researchers are exploring is if VIT could actually learn in a more self-supervised manner.
Okay.
Similar to how some language models can learn from tons and tons of text without needing everything to be specifically labeled.
Hold on. Are you saying that we could potentially unleash VIT on, the internet, a sea of images, and it would just figure things out on its own?
Right.
No more hand feeding it millions of labeled pictures?
That's the ultimate goal.
Wow.
Now, it's still early days, and the accuracy hasn't quite reached the same level as the more data-intensive approach, but the initial findings are actually really promising. And it opens up some really, really interesting possibilities for the future.
So we're talking about a future where VIT could, teach itself to understand images. That's mind-blowing.
Yeah.
But let's bring it back down to earth for a second. Why should any of this matter to, the average person? How could this impact, our daily lives?
Well, that's what's so exciting about it, right?
Yeah.
Imagine a world with, faster and more accurate medical diagnoses. Because, machines are analyzing scans and images with incredible precision.
Yeah.
Catching things, way earlier than ever before.
Okay, now you're talking. That would be a game changer.
Exactly. And it doesn't stop there.
Yeah.
Think about, self-driving cars navigating busy streets with even greater safety and reliability.
Yeah.
Or how about being able to search for clothes online simply by showing an image
Oh, okay.
instead of having to rely on keywords? So this technology could revolutionize how we shop, interact with our devices, even experience art.
I love how this paper has gotten me thinking about the connections between how our brains process language and visual information. It's like VIT is blurring those lines.
It really is.
Yeah.
This research suggests that maybe those lines are a lot more blurred than we originally thought.
Yeah.
And that opens up some really, really exciting questions.
Exactly. What are the limits of this technology? What else could we unlock if we continue to bridge this gap between language and vision? That's something to ponder, isn't it?
It sure is. It seems like we're just scratching the surface of what's possible. The future of computer vision is, it's looking more intriguing by the minute.
I couldn't agree more. Well, thanks for taking this deep dive with me today. Until next time, keep those imaginations firing.